In this lesson, we are going to work on writing linear inequalities from graphs. Let me focus this so it's not so, there we go. All right, so this is the first graph we're going to look at. So we're going to use what we did yesterday with graphing to help us figure out what our inequality equation, or excuse me, our linear inequality should be. So one of the first things we're going to look for is if our graph has a whole number y-intercept. And in this case, it does. So since I have a whole number y-intercept, I'm going to use slope-intercept form. We're going to look at some other examples where I do not have a whole number y-intercept, and those we do differently. But since we have a whole number y-intercept, we can do slope-intercept form. So the next thing I need to find is my slope. And so I see another point here. So one thing I notice is our slope is negative because it's decreasing. And I'm going down 4 and over 1. So the slope would be negative 4 over 1, which is the same as just negative 4. So like I said before, since we have a whole number y-intercept, I'm going to do slope-intercept form. So that would be y equals mx plus b. I'm going to leave my inequality sign alone for just a second. So I'll have negative 4x plus 4. Now I have to figure out what inequality sign is going to go here. One thing I notice is I am going to have an equal to because this is a solid line. Now I have to figure out if y is greater or if y is less. And I can do that with the point 0, 0. It's not shaded over, so I know my statement is going to have to be false. So 0, and then I'm going to compare that to negative 4 times 0 plus 4, which would be 0 and 4. If I want this to be false, I would say 0 is greater than or equal to 4, and that's how I would write a false statement that shows my shading here. Another thing you can look at, since the shading is up above the line here, having the shading be above the line is another indication that my inequality sign should be greater than. Next one we're going to look at is here. So I have another slope that is negative. And in this case, I do have another whole number y-intercept. So this is going to be another slope-intercept inequality. And so my y-intercept is 1. And looking here at my slope, the next point is on the next corner tick mark. So that makes my slope negative 1. So I'm going to go ahead and start my slope-intercept form. Now I notice the shading is up above, so 0, 0 would be false. So I'm going to test 0, 0 just to make sure. And I have 0 and then negative 0 plus 1. Well, negative 0 is just 0. It doesn't make any sense. So 0 and 1. Again, this has to be false because 0 is not shaded over. And it's not going to have an equal to because this is a dashed line. So that would be my inequality statement for this graph. All right, here's the next one we see. Let's see if I can make this a little bit brighter. There we go. So right away, I notice I do not have a whole number y-intercept. So that takes slope-intercept form off the table, and I know I have to do point slope because I have a fraction y-intercept. So I'm going to find 2 points that are on tick marks, and I'm going to do the slope between them. One thing I notice is that it's a decreasing line, so it's negative. And I'm going down 1 and over 2, so it would be negative 1 over 2. Now it does not matter which point you choose to use. I am going to use this point, which is the point 1, 0, only because it makes our lives a lot easier if I have a 0 as one of my coordinates when I write point slope. So I'm going to have y minus 0 and then negative 1/2 times x minus 1. Well, anytime I'm subtracting 0, this, I almost wrote an equal sign. Whoops. This is going to turn into this inequality because minus 0 doesn't really mean anything. And now I have to figure out if it's greater than or less than. I am not going to have an equal to because the line is dotted. So 0, 0 would be false. So I have to write a statement that is not true. Another thing I noticed is the shading is up above. So my gut reaction is that y is going to be greater than, but let's double check just to make sure. Well, 0 minus 1 is negative 1 times negative 1/2 would be positive 1/2. And for this to be false, because remember 0, 0 is not shaded over, 0 is not greater than 1/2, so that would be my false statement. So yes, in fact, it should be y is greater than this function. Now, if they asked me to put this in standard form, where x and y are together, what I'm going to start by doing first is multiplying by 2. So I'll have 2y is greater than negative 1 times x minus 1. Of course, my screen is going to freeze. Just bear with me. And then I'm going to distribute this negative over here. So I'll have 2y is greater than negative x plus 1. Then I'm going to add x to the other side. So I'll have x plus 2y is greater than 1. So this would be the standard form. And this is our point slope. Two more that we're going to look at, just to keep our brains in this continuous process of remembering vertical and horizontal lines are used as well. Now I know it's really hard to see. This is a dashed line. So since this is a vertical line, I know vertical lines go with x. So this would be at x equals 1. And since it's shaded over 2, 3, 4, 5, and so on, it's all the numbers for x that are greater than 1. And since it's dashed, it is not equal to. And the last one we're going to look at is a horizontal line. And this is a solid line. I drew that in for you. And a horizontal line goes with y. Since it's a solid line, I know I'm going to have an equal to in my inequality. This is at 3 for the y value, and it's shaded over 4, 5, 6, 7, and so on. So that means it's the numbers that are bigger than 3. So a couple important things to remember. If it's a problem like this, where I have a whole number y-intercept, I can go straight to slope-intercept form using the slope and the y-intercept. If it's a case like this, where I have a fractional y-intercept or it's not on a tick mark, I have to use point slope form.